Imagine a world where data flows freely and securely without the constraints of centralized oversight. A digital domain where applications function with unparalleled efficiency and transparency. This isn't a snippet from a sci-fi novel, this is the reality being woven by the graph in the realm of Web 3.0 applications. In an era dominated by discussions around blockchain and decentralization, the graph emerges not merely as a tool but as a cornerstone technology that is vital for the operational success of decentralized apps, or dApps. Its role in enhancing data accessibility and processing efficiency is not just noteworthy, it is revolutionary. As we dive deeper into the fabric of decentralized technologies and their imprint on our digital interactions, understanding the graph's capabilities becomes crucial. Introduction to the graph. Enabling the decentralized web. The graph is essentially a decentralized protocol for indexing and querying data from blockchains. Starting with Ethereum. It allows developers to build powerful dApps with the ability to access blockchain data efficiently through the use of GraphQL. This isn't just another database service. The graph facilitates a new way of interacting with and visualizing the data that drives decentralized applications. In a layout that typically involves numerous moving parts. The graph streamlines data querying, which could otherwise be staggeringly complex and slow. Imagine querying a traditional blockchain setup for specific data across multiple blocks and transactions, and you can begin to appreciate the level of simplification and speed the graph introduces. Data in the graph is processed by a decentralized network of servers, known as indexers, who stake the native GRT token to provide indexing and querying services. This decentralized approach not only ensures data integrity and availability, but also makes the graph a key player in the drive towards a fully decentralized web. The graph at work, case study of Uniswap. Uniswap, a leading decentralized exchange, or DEX, that runs on Ethereum, leverages the graph to fuel its interface and backend, making real-time data querying seamless and effective. Consider how Uniswap manages large volumes of token swaps every day. The graph enables the DEX to access historical and real-time transaction data without the need for centralized servers. The utilization of the graph by Uniswap demonstrates the protocol's robustness in handling high data demands in live environments. Here, the graph's GraphQL API plays a pivotal role, offering developers the tools to create responsive and intuitive user experiences. The graph's impact on Uniswap extends beyond technical enhancements. It underpins the trust and reliability that are crucial for the adoption and growth of decentralized platforms. Users and developers alike can trust the data integrity, thanks to the graph's decentralized nature. The impact of the graph on data accessibility and efficiency. The introduction of the graph has reshaped how data is handled within decentralized environments. By decentralizing the querying process, the graph mitigates the risks associated with central points of failure and attacks, which are significant concerns in traditional systems. Furthermore, the graph enhances data accessibility. Developers can construct and publish subgraphs, which define how blockchain data is ingested and processed. This means that any dApp on supported blockchains can potentially tap into a rich ecosystem of already processed and accessible data. The efficiency gained from using the graph cannot be overstated. By providing quicker access to data and reducing the load on the main blockchain, the graph conserves resources and improves dApp performance, thereby fostering a more scalable ecosystem. The future, the graph, and the evolution of decentralized applications. As we move forward, the implications of technologies like the graph on our digital infrastructures are profound. With the increasing need for decentralized solutions that offer security, privacy, and efficiency, the graph stands out as a beacon of potential. The future of decentralized apps looks promising. With the backbone technologies like the graph, we can anticipate broader adoption across various sectors, including finance, governance, and beyond. Enhanced data handling capabilities that the graph provides can drive innovations in AI, machine learning on blockchain, and complex decentralized autonomous organizations, or DAOs. In conclusion, the graph is not just enhancing current applications, it is paving the way for the next generation of digital solutions. Its ability to democratize data access while ensuring efficiency and security is perhaps one of the most significant developments in the blockchain space. As we continue to witness the growth and evolution of Web 3.0, the graph will undoubtedly play a crucial role in shaping this new digital frontier.